Hello everyone, it's indeed inspiring to see you back again. And this is tutorial number 3 under Big Data series. Today we are going to discuss understanding and planning of Hadoop clusters. Probably this video will have two parts because I need to give you in-depth understanding of what is Hadoop's architecture. If you are planning a cluster, then how you can plan a cluster. If you want to set up for practice, you want to set up a lab cluster, or if you want to have an industry level deployment, I'll give you all sort of understandings. So let's begin without wasting any time. Okay, so let's have a recap of big data. Big data refers to massive, complex, structured and unstructured data sets. So I'll repeat, massive, okay, large scale, complex, so that it's not easy to handle them. Structured and unstructured data sets that are rapidly generated and transmitted from a wide variety of sources. If you're working in a company, you may have some internal sources of data like ERP systems are there, LMS, learning management system is there, content management, customer management, so HRM, so many softwares can be there which will produce data, which will generate data. Okay, and after that you may have some services, some products which will have some social presence. So from there also external sources of data will get generated where general public can show their interest, they can comment, they can request. Okay, so many things can happen even outside platforms of the company. So internal external sources of data, and we basically process this data to have some, to leverage some insights out of them. We need to store this data so that ultimately we want to process it, so we require some storage space. Okay, now let us discuss about Apache Hadoop because it emerged as a one-shot solution at one time, and it gave us two solutions. One is storage solution and another is processing solution. The storage solution is distributed data storage, processing is distributed data processing. You can see here both of them are having the word common, distributed. That means you don't have a single CPU, one CPU. No, you don't have a single CPU. You have multiple CPUs, or you can say multiple servers. And in these multiple servers, your data is going to get stored. Is your data going to get stored as a single chunk, single piece? No, it is going to be divided into smaller blocks, and smaller blocks are going to be stored into multiple CPUs. That is actually called as distributed data storage. Okay, similar way, once your data is split it into smaller chunks, so small chunks will get processed after that. So the processing is going to take place in multiple CPUs parallelly. Therefore, this is distributed data processing. Rather, I would say distributed parallel data processing. Okay, so these two solutions actually Hadoop gave us as soon as it was developed. It was the project was completed. Okay, now let us understand more on it. This is the Hadoop's architecture. You can see that I have again separated out two parts. One is distributed data storage, that is called as HDFS. So just remember this name, Hadoop Distributed File System, HDFS. And the second one is Yarn, yet another resource negotiator. So this is the current frameworks which Hadoop gives, or current solutions which Hadoop gives. Here you can see we have important components as name node and data node. So these are the two main important components. We have another component called as secondary name node, which is not so compulsory here. So we will see everything, all of those things. Okay, now here you can see distributed file system. File system, I believe everybody is aware of. You know what is a folder? Yes, I believe if you are using a laptop or a computer and you are using any operating system, Windows or Linux or Mac, you create folders, or we call the folders as directories, and you save or store your files inside the folders. So this is a part of file system. Okay, how the files are organized in folders, and folders are organized within the folders, subfolders are there. Okay, so folders and files, they together make the file system. So this is also a file system where you will have some folders, some files, all these things will be there. Okay, now this distributed file system is created with the help of NN, which is name node, DN, which is data node. So data nodes and name node, they together come and they create this Hadoop distributed file system. Data nodes are installed on CPUs. Name node is also installed on a CPU, and name node is the master component. Data node is the slave component. So a lot of slave components, like thousands of data nodes can be there, and all these CPU will offer their hard disk drives to store the data. Okay, so they will offer their storage because of the data node component. Okay, this is how we scale up in the storage solution. We will discuss in detail about it. This is just a high level idea I'm giving you here. Second part is yarn. That is yet another resource negotiator. This is very much helpful in processing, because for processing we require certain amount of resources. So resources are managed by this yarn, and we also require scheduling, that which job should be processed first, which should be processed second. Scheduling is also required. So this framework also help us in scheduling. Like a task can have 10 subtasks. Okay, so 10 subtasks will be scheduled. Okay, whether they need to be run parallelly or one after the other. All this is managed by the yarn. It has got important components like yarn manager is there, node manager is there, and I'm sorry, resource manager is there, and node manager is there. Resource manager has got something called as application manager, and which is helping out resource manager to create application masters and establishing containers. Okay, so all these things will be very new to you, so don't worry, just remember resource manager and node manager. We will discuss everything in detail. Let's move ahead and discuss further. So now moving ahead, now we have HDFS, that is Hadoop Distributed File System. Let me tell you at very high level, which I will cover in depth also. Client is somebody who wants to store some data or who wants to retrieve, download some data. Upload, download, you can say, okay, get and put, you can say whatever terminology you want to use. So ultimately client has some data, want to store it, and later on client wants to read it. So client will make a request to the name node, because name node is the master, and in his name node, it is the master. And then we have data nodes. So we have multiple data nodes. I told you multiple data nodes, they are installed on a CPU. One CPU will have one data node. So here we have three CPUs and they have data node component. Let's say 1 TB is the storage in them. So total storage we have is 3 terabytes. Okay, so less than 3 terabytes, because we know that some other files, some operating system, they will also consume some space. So we'll have less than 3 TB. In general, I'm saying, let's say around 3 TB storage we have. So name node will basically guide the client. Okay, you want to store some data, I have storage, so you can store it. So go to the data node 1 and you can store your data. Okay, so what is happening? Name node is the coordinator. It is the coordinator. It coordinates between the client request and the data nodes. Okay, for storage as well as for reading purpose, for deleting purpose, for moving purpose, for copying purpose. A file system, what happens in a file system? We create something, or we upload something, we delete something, we move something. So all the file system related operations, name node is the coordinator, and it coordinates between the client, the external entity, and its own data nodes, its own members. Okay, let us move ahead and try to understand more on it. Now, there are certain assumptions and goals. First assumption is that hardware failure is a norm. Okay, so we assume that hardware failure we are going to face. Okay, we don't assume that, okay, it might get failed. No, it is going to fail. It is going to fail. So it is an assumption that hardware failure is a norm. So what happens? We have hundreds and thousands of servers. Okay, you can see in the image. So hundreds and thousands of servers are there. Okay, servers means CPUs are there, where we install data nodes. I'm just talking about, let's say, HDFS part, data nodes, and name node is there in some CPU, some server, right? So these data nodes, thousands of data nodes, they may fail. We know they may fail. Okay, so therefore, we have HDFS framework designed in such a way that these failures are very quickly resolved. Okay, quickly they are resolved automatically. So that is how name node has got certain policies, certain you can say rules, that if a machine is failed, then what should be the alternative? Name node takes that action quickly. So this is an assumption that hardware will fail and the name node is going to handle that part. Second is streaming data access. So streaming data access, the Hadoop applications, they actually require streaming data, currents of data, live data analysis. Okay, you might have seen that the sports match is going on and live data analysis is being done. Some environment changes are being happening and the data is being captured live and some sort of analysis is being done. So real-time data analytics is something a need of the hour, and the applications of SDFS, they actually require streaming data. So therefore SDFS is designed in such a way that okay, batch processing, as soon as a stream of data is coming, that can be processed. Stream of data is coming, that can be processed. So there is no interactive. If you have worked with some maybe Python Jupyter notebooks or Linux shell, so that is interactive. MySQL shell, that is interactive. So SDFS is not designed in such a way. SDFS is designed for batch processing. Okay, so you are having the data coming in and you process it. You are having another set of data coming in, you are processing it. Okay, so this is the kind of design SDFS has been given. Now, POSIX. So POSIX is basically, generally, if you see all the file systems, they are having POSIX structure. Okay, that is basically relaxed here. That is relaxed here, so that we can get better throughput in case of SDFS. Now, moving towards the next part, large data sets. So this is again another assumption, because of big data, large data only, the SDFS was designed. So it is better for gigabytes to terabytes or petabytes of data, rather than you store KBs and MBs of data. So this is another assumption of SDFS, you can say. So it supports large files. Okay, now up moving towards next one. Now, simple coherency model. Okay, so what is this? I'll tell you. So with the help of the image, you can see that if something is happening at one part, so you look at this. Okay, some sort of smoke is being produced by this particular piece of entity, and exactly the same sort of smoke is produced on the second image. Okay, so just for making the analogy, I have put this image. So what this basically means, SDFS applications needs a write once and read many. Okay, write once and read many access model. So there can be multiple users accessing the same data. There can be multiple applications which are accessing the same data. So write once. That means SDFS is immutable. It does not allow mutability. So you have one data, and that data is as it is available to all the users, all the applications. I believe you're getting this point, right? If I keep on trying to change the data, so the data is stored into multiple machines. It may happen that at one machine it is updated at one time, and it may take some time for the data to be updated on some other machine. Okay, so in order to avoid that, in order to make it coherent, in order to make it identically available to all the users, it is write once and read many. Okay, once we write, but here we can append and truncate. Append truncate means at the end you can append something, or from the end you can delete something. So that is allowed, but in between you go and you try to edit and modify like we do in databases, that is not allowed. Okay, so this is simple coherency model of SDFS. Another part is moving computation is cheaper than moving data. IO operations are a biggest, one of the biggest bottleneck in processing. The processing takes, let's say, 10 minutes, and your input and output of the data, it takes 1 hour. So what is the use of that IO operation? So rather than moving the data, like rather than IO operations, can't we move computations, processing to the data itself? So that will be cheaper in terms of time. If time is getting saved, obviously the money is also going to save, right? So moving computation is cheaper than moving data. So here, whenever there is some task being running, it prefers local computation. It does not prefer that data should move from one CPU to another CPU all the time. So it will always try to execute the data locally, so that it saves the IO operations, it minimizes the network congestion, and it increases the overall throughput. So this is what is another feature, or aim with which the SDFS has been created. Another important part is portability across heterogeneous hardware and software platforms. This is another beautiful feature which SDFS gives us, because this allows multiple applications to get integrated with SDFS, or multiple platforms and applications, they adopt SDFS as storage purpose. One example is Spark. Okay, Spark leverages the capability of SDFS, and then it processes the data. Okay, this is just because of portability. Next part is now Yarn. Okay, so we just discussed about SDFS framework. Okay, now we are coming to Yarn, yet another resource negotiator. Let me tell you before we begin. So at the time of beginning, it was Hadoop 1.x, and with 1.x we had job tracker and task tracker at the beginning, and then the framework was changed. There was a major change, and Yarn framework was evolved. So we will talk someday for the job tracker and the task tracker as well. Now let us talk about this newly framed framework, which is yet another resource negotiator. So here we have components like resource manager and node manager. And here we have a client. Client has got a a program or a job to be processed, to be run. So client basically makes a request to the resource manager. Resource manager further manages out everything. So resource manager has got a supportive component which is called as application manager, and it has got one more component which is called as scheduler. So two things it has got: AM as application manager and S as scheduler. So application manager helps resource manager to create one application master for that particular job, which will handle the whole of the job. It is very similar to, let's say there is a builder and builder has got 10 projects. For one project, builder will take a contractor and will give the whole work to the contractor. Okay, so the builder is having one person as application manager, another person as scheduler. So application manager will bring that contractor, that is application master, and application master will be given all the responsibilities. Scheduler will help to schedule that which task should be done first, which task should be done second. That is a task of scheduler. Okay, so again, high level, I will tell you in very depth in the upcoming videos. Okay, let's move ahead and try to understand further. So Hadoop Yarn. So what is Yarn? This is basically, as I was telling, that this is split into two major things. One is resource manager is global. Okay, resource manager, it is global component which manages out everything. And there is application master. Application master, if we have one application, we will have to start one application master. If we have 100 applications, we will have 100 application masters started. Okay, are you getting this? So one resource manager, under one resource manager, you can have n number of application masters, and this n is number of jobs. Okay, so the number of jobs you want to run, those many application masters. Now let's understand further. So node manager is also there. So these application masters start inside the node manager. So node manager are CPUs, different CPUs. Inside these CPUs, these application masters actually start. Okay, now let's move ahead. So here we have node managers. So what is the task of node managers? Node managers are slave components, and they are stored across thousands of machines. Now, like name node, one master and multiple data nodes. Similar way, resource manager, one master and multiple node managers. So node managers share the CPU with data node. Okay, the other slave component as well. So two CPUs we will have. So here you can see two CPUs. So one I'm taking as resource manager, another I'm taking as node manager. So resource manager will manage out the node managers at very high level. Resource manager is going to manage the number of node managers. Okay, now understand. So in node manager, we will have application master started. So always the application master will start in node manager. So if the application master is getting started in the node manager, then what is going to happen? So at that particular point of time, that application master is going to handle that particular job. So hundreds of jobs, hundreds of application masters in multiple node managers will run. Okay, these application masters again utilize the node manager, more than one node manager, to get the task completed. So this is how the whole architecture actually works. Okay, so permission is given by resource manager. So that is the authority from whom how many resources to be used, which how the scheduling needs to be done. So that is the authority. Fine. Let us move ahead and try to understand that how a job gets executed. So here we have a client which has got a program to be executed. Client requests the name node. So step one is client is making a request to the resource manager. This resource manager is then actually it interacts with the name node, that where is the data. So it has continuous interaction with the name node. So that I have not mentioned here, just to keep it simple. So resource manager will take that job and will take the help of application manager to start the application master. Okay. And similarly, there was another job given. For that, it will again take the help of application manager to start one application master. So these application masters are responsible for single job. Okay, so job 2 is handled by this application master, job 1 is handled by this application master. They have container. So container is basically, they will get a set of resources. So those resources are virtually, you can say, bind by that container. Container contains all the information of how many resources: memory, cache, hard disk, processor. So how much capacity of these resources this application master is allowed, that will be put into the containers. All right. So this application master is going to use these resources, get the task executed by the node manager worker nodes. And once the job is completed, it will report back to the resource manager. It'll get the final status. Okay. So this is how the whole job actually gets processed in case of Yarn. Now let's talk about scheduler. So once the job is getting started, so that time two things. One is application manager. So application manager is going to start the application master. Scheduler is going to create the schedule, okay, that which job should run what time. So that whole policy scheduler does. Okay, so we have different schedulers. We have capacity scheduler, we have fair scheduler, even we can have custom scheduler of our own. We can design a scheduler and we can fit in into the Hadoop architecture. So that will basically decide that how the job should get scheduled. This can also happen given to the users also. Different users can get different capacity for resources. Okay, so this is the scheduler part. Next part is application manager. So as I told you, so for job handling we require application masters. So application manager is responsible for job submission, negotiating with the container for executing applications. Okay, so it actually starts application master. It negotiates for the resources, it gives those many resources which are contained inside a container, and then application masters executes it. Okay, so once again, to summarize about resource manager, it has got two components. One is scheduler and second component is application manager. Scheduler looks after the scheduling of the job, okay, which one to run first, which one to second, which one to parallel. And application manager is responsible to initiate application master, and application master is basically handling the whole job. Okay, so this is how the responsibilities are split up. Now, MapReduce. So MapReduce became one application. So one type of job is MapReduce. So you can run MapReduce type of jobs utilizing your yarn, okay, with the help of resource manager. And the previous versions like Hadoop 1.x, 2.x, so there is the APIs are very much compatible with the previous version. So whatever jobs you will write now are compatible with previous versions as well. Okay. Next is resource reservation. So this resource reservation is a concept which allows users to specify a profile of resources over time and temporal constraints. Okay, that means that if you are a user, you need some resources for, let's say, a week's time. So resource reservation system, so there's a component, it can allocate those resources for you, and those many resources are blocked for you. Nobody else can use them. Okay, so resource reservation system, it basically does this part. It keeps a track of the resources, and after the ensured time, it releases those resources. So this is another component in resource manager. All right. Now federation is one more concept in Yarn. This federation is basically that, let's say if you are increasing the number of node managers, so one resource manager has got limitation. It may not be able to handle after 2, 3, or 4 thousands of node managers. Then what to do? Then basically you can have federation. Federation means you can have more than one resource managers parallelly working. So here you can see we have subcluster 0, subcluster 1, subcluster 2. So we have one R, that is one resource manager, it's backup, okay, standby. Another resource manager, it's standby, okay, and we have another resource manager and it's standby. So we have 3 resource managers parallelly running as a subcluster. So if one resource manager is able to handle 3000 node managers, so here 3 plus 3 plus 3, 9000, so much big size cluster you can have with the help of federation concept. All right, so I hope you like this concept. This was the fundamental assumptions, objectives, and aims of SDFS and Yarn, which comes under Apache Hadoop. Now, in the next video, I'll take you in the depth of the architecture. Do like, share, and subscribe. Thank you. Thanks a lot for watching.